Let's do an example where we go over how a compression or stretch will affect the graph of a function. So let's look at this function given to us in table format. So the function has the points -3, 1, 0, 2, 3, 2, 5, 0, and 7, 2 on its graph. In other words, when you plug -3 into the function, -1 comes out. When you plug in 0 into the function, 2 comes out, etc. We're going to look at the transformation when we multiply 2 by the outside of the function. We're also going to look at the transformation when we multiply 2 by the inside of the function. What happens when we multiply the outside of the function by 1/2? And finally, what happens when we multiply the inside or the argument of the function by 1/2? So we'll start off by graphing these points and connecting them to create a function picture. And then we'll go ahead and see what the transformations each of these does to each of the 5 points, and then we'll graph those. Let's begin with the transformation of multiplying 2 by the outside of the function. Multiplying by the outside of the function affects the y-coordinates of the points on the graph. So we're going to multiply each of these y-coordinates by the number 2. -3, -1 will become -3, -2. 0, 2 will become 0, 4. 3, 2 will become 3, 4. 5, 0 will stay 5, 0 because 0 times 2 is 0. And 7, 2 will become 7, 4. When you multiply the outside of a function by a number greater than 1, you get a vertical stretch. First, let's look at what the graph of the original function looks like. We have each of our points, -3, -1, 0, 2, 3, 2, 5, 0, and 7, 2. And the way that I've chosen to connect these points is an increasing portion here, a constant portion here, and this curve or parabolic arch here. Now let's go ahead and plot our blue function, which is a vertical stretch when we multiplied each of the y-coordinates by 2. -3, -1 becomes the point -3, -2. 0, 2 becomes 0, 4. 3, 2 became 3, 4. 5, 0 stayed where it is. And 7, 2 became 7, 4. And if we connect these dots in the same pattern, you can see how this graph is now vertically stretched compared to the original graph f of x. Now let's see what happens when we multiply the inside of the function by 2. Multiplying the inside of the function by 2 means that we are multiplying the x-coordinate now. But you're multiplying the x-coordinate by the reciprocal of the factor. So this becomes a horizontal compression. When we apply a horizontal compression, we multiply the x-coordinate by the reciprocal of this a value. So the reciprocal of 2 is 1/2. So -3, -1 becomes -3/2 -1. 0, 2 stays 0, 2 because 0 times 1/2 is still 0. 3, 2 becomes 3/2 2. 5, 0 becomes 5/2 0. And 7, 2 becomes 7/2 0. Now let's graph these points. -3/2 -1 is -1.5 -1. So -1.5 is about right here. And then we want to go down to -1. So we're looking at this point right here. 0, 2 is still here. 3/2 2 is 1.5, 2. So that's about here. 5/2 is 2.5 or 2.5, 0. And 7/2 is 3.5, 2. I see I made an error up here. This should be a 2. So we have 3.5, 2. So we're looking at right here. So you can see that this is the original shape as f of x, but it has been horizontally compressed. Let's go ahead and move on into what happens when we multiply the outside of the function by 1/2. Again, multiplying by the outside of the function manipulates the y coordinate. So we're going to be multiplying all of the original f of x values y coordinates by 1/2. So -3, -1 becomes -3, -1/2. 0, 2 becomes 0, 1. 3, 2 becomes 3, 1. 5, 0 stays 5, 0. And 7, 2 becomes 7, 1. So when I plot each of those points for our yellow function here, you can see our graph, again, it's the same shape, but it has been vertically compressed, smushed from the top and the bottom. Now let's focus on our last transformation here that we'll do in red. Here we're multiplying the inside of the function by 1/2. So that means that we are going to multiply the x coordinate by the reciprocal of 1/2. So the reciprocal of 1/2 is 2. So we're going to be multiplying each of these x coordinates by 2. Multiplying each x coordinate by 2 gives us these points, which we'll plot down here. Once I plot all those points, and again I'll connect them in that same pattern, increasing line, constant line, parabolic arch, you can see that this graph again has the same shape, but it is stretched out. And it is stretched out in the horizontal direction. So this activity was a good example of how multiplying either the inside or the outside of the function affects what the graph looks like. Remember, the outside of the function will affect the graph in the vertical direction, while the multiplying the inside or the argument of a function by a number will affect the graph in the horizontal direction.